Good morning, everyone. Thought I'd start with a dad joke today. My daughter told to me yesterday, why is it better to brush your teeth before you go to bed than after? Answer? Because it's too messy to brush your teeth in bed. Yeah, no. Okay, good morning. Welcome to math. Let's get started. Today's lesson. Hopefully by the end, everyone will say that they can divide a whole number by a unit fraction. The mechanics of this are quite simple. What we want to make sure that you understand today is why it works, what you're actually doing when you divide a whole number by a unit fraction. Let's take a look at another example of sharing and grouping so it's in our head so we understand what we're talking about. So here's a division problem, simple one. 10 divided by 2, of course, is 5 because 5 times 2 is 10. So a sharing example of that would be $10 being split among 2 kids. Each child would get $5. We know how many groups there are, 2. We just don't know how much they each get. We do the division, they would get 5. A grouping example of that would be Legos, 10 Legos being put into piles of 2. So we know how many are in each pile, but not how many piles we could make. We would run out after we made 5 piles because 5 groups of 2 equal 10. So that's sharing and grouping. Hopefully you're more comfortable with those two terms and which is which after a couple lessons on it. Let's now take a look at 10 divided by a half, at a sharing and grouping example of this. Take a look at these two little situations. Imagine 10 cookies shared with half a person. Or 10 cookies split into half-size pieces. Now that I can imagine. If you were to have 10 really big cookies and you want to share them with people, you could cut them in half. You could group them by halves. But I don't think, just ignore my phone beeping, sorry about that. I don't think you can share with half a person though. So if we go to the next screen, we see that I've X'd out this sharing situation because this is impossible. You can't have a whole number divided by a fraction and have it be a sharing division problem. It just doesn't make any sense. So all of our examples going forward for a whole number divided by a fraction will be grouping division problems. So let's take a look at those 10 cookies. So imagine that these circles are cookies and we want to divide them by half, which means we are dividing them into half cookie-sized pieces. So I can imagine that you would understand that there would be 20 pieces because we had 10. Now there's 2 each, 2 halves for each cookie. 10 twice is 20. So the answer to 10 divided by half is 20. But what did we do mechanically here, mathematically, between 10 and a half to make 20? Yesterday we sort of hinted at this, that 10 times 2 is 20. So remember, when we do division, division is the opposite of multiplication. And the mechanics of this, as you guessed yesterday and today, when we are taking a whole number and dividing by a fraction, we wind up multiplying the whole number by the denominator to equal a whole number answer. So it was 10 times 2 equals 20. Let's take a look at another example. It takes a third of a yard, not a whole yard, but one piece of a yard, a third of a yard, to make a hair bow. Maya has 5 yards of ribbon. She has 5 whole yards. How many hair bows can she make? Well, let's think about what the equation would be. Start with how many yards of ribbon she has and what kind of pieces she's going to cut it into. She's going to group it by what size piece. I want you to try to write down the equation that would go along with this word story problem. So pause the video if you need to get out your notebook and pencil, or maybe write it in your head. I'm going to wait a few seconds. You can pause if you need more time. The equation would look like this: 5 yards of ribbon being divided into pieces that are 1/3 of a yard each. So how many hair bows can she make? If she has 5 whole yards divided into pieces that are only 1/3 of a yard, so I'm thinking that means each yard can make 3 ribbons. So the answer must be 15. Now remember, mechanically, we do the whole number times the denominator to get 15. Let's take a look at a model of this. This looks really confusing at first, but let's break it down. It's not that bad, and it actually sort of demonstrates what we're doing. Here's our number line from 1 to 5. So these are our 5 yards. And because we only need 1/3 of a yard, each yard was cut into 3 pieces: 1/3, 2/3, 3/3, and there's your first yard. Here's the second yard: 1/3, 2/3, 3/3. I'm going to highlight each yard, and we can see that each yard has 3/3 in it. And since a hair ribbon only needs one of those 3, we can easily now see that we have 15 of these sections. So we took 5, broke each of the 5 into 3 sections, thirds, and so now we have 15 pieces. So she can make 15 hair bows. Another way to draw it would be to draw each of the 5 yards separately, yard 1, 2, 3, 4, and 5, and split each one into thirds, and we can see that we have 15 of them. Here's another situation. Oops, I gave away the equation. I did not mean to do that. I meant to have it covered. Pretend you didn't see that. Whoops. Our aquarium holds 5 liters of water. If we use a scoop that holds 1/6 of a liter of water, how many scoops will be needed to fill the aquarium? Well, our equation would be the 5 liters of water grouped or divided into groups that are 1/6 of a liter each. So we would take the whole aquarium and think, how many little 1/6 scoop sections could we make? Let's take a look at a picture of all. Let's solve it first. Mechanically, remember, I'm having a hard time getting rid of that. Okay. I want a pen. I'll use this pen. Mechanically, we take our whole number and multiply by our denominator. And 5 times 6 is 30. So we would need 30 scoops to fill the aquarium. Because each 1/6 is not a whole liter, it's only one piece of a liter, we would need 6/6 or 6 scoops to make 1 liter, and we would need to do that 5 times. So we wind up doing 5 6 times, or 6 5 times, to be 30. Here's a picture of that. Here are the 5 liters, each liter divided into sixths. So we see we have 6 pieces here, 6 scoops here, 6 here, 6 here, and 6 here. 6 5 times is 30. Here's another picture of it. We draw the whole aquarium, and each layer is a liter. And then we've divided those 5 liters into 6 across. 6, 1, 2, 3, 4, 5, 6 1/6 liter sections. And we have 6 5 times, or 6 plus 6 plus 6 plus 6 plus 6 is 30. So again, mechanically, the whole number times the denominator gives you your whole number answer. Today, for an assignment, we're going to give you 2 pages to practice this. I want to do this first one with you so you have an idea of what it'll look like, how to do it. You might not need to draw a picture, but that is always there as an option for you in case you need to be able to see it. It gives you some choices. It says solve each of the story problems below. For each problem, it says choose and circle one of the numbers in parentheses depending on how challenging you want the problem to be. So you'll notice there are choices. Let me read the situation and we'll see which one we want to do. It takes blank of a cup of sugar to make a batch of cookies. I have 5 cups of sugar. How many batches of cookies can I make? Okay, so clearly we'll be able to make more than 5 batches as it's only going to take a fraction of a cup to make a batch of cookies. Well, let's go back to our directions, and it says circle and choose one of the numbers in parentheses. I'm going to choose, just because I want to make it simple for our demonstration, I'll choose fourths. Okay, then it says write an expression to represent our problem. So I'm going to scroll down a little bit. We have 5 cups of sugar, and it takes a fourth of a cup to make a batch of cookies. So I'm taking my 5 cups of sugar and I'm grouping them or dividing them into 1/4 of a cup batches. How many batches will I be able to make? Well, I know that mechanically I do 5 times 4 is 20. I'll be able to make 20 groups of cookies. For the third bullet, it says use numbers, labeled visual models, or words to solve the problem and explain your strategy. We won't, from a distance, be able to see a model that you draw, so you might be able to just explain to us what you see. I'll leave you a little bit of space for you to type something to explain your strategy, and then there is a blank for you to complete the sentence with your solution to the problem. Going forward, the rest of them look like this. A place for you to write your expression, and then a place for you to answer it. I have recommended that we not use the more challenging choices, as those will be difficult without me there to help you through it. I would stick with the first few, the whole numbers, the unit fractions. If you really want that extra challenge and want to do this harder one, by all means, you can give it a shot. You can go for it, and then we can talk via email or maybe on the phone or something if you need help with it. But to begin with, I would stick with the ones that I have highlighted here in yellow, as they are much more approachable, especially the first time through it. Same thing on the second assignment, which would have been from your home connection books. The examples, there are some that are unit fractions, and then some that are not, where the numerator is bigger. And the first time through, that might be too much of a challenge. But if you're up for it, give it a shot. Why not? It's not like you don't have time, right? Right now, I would very much like for you to remember a skill that we haven't practiced in a while. I would normally give this to you as an exit ticket and collect it, but I want to give you a chance to just practice it right now. So here are 4 problems of a whole number multiplied by a fraction, because it's been a while and we haven't done it in a while. So let's just practice 4 of them quickly. I'm going to pause the video, or you pause the video, take as long as you need to solve these, and press play when you're ready, and we'll go over them together. I'm going to wait a few seconds before I start talking to give you a chance to pause. Remember that there's more than one way to solve these. Okay, here we go. 6 times 1/3. Well, I immediately notice that 6 can be divided by 3. So I'm thinking I'm going to do 6 divided by 3 is 2. And my numerator of 1 says I only need 1 of these, so the answer is 2. Sorry about that. My phone's yelling at me. Another way to do it might have been to simply do this part and wind up with 6/3, which of course can be reduced to 2. Now 3 times 1/3, this should have been pretty obvious to everyone, equals 3/3, which of course equals 1 whole. Now down here, 5 times 1/4. Can't really do 5 divided by 4, but we can write it as 5/4, because 5 times 1/4 means 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4. Was that 5? 5/4, of course, we can pull a whole out, 4/4, that's 1, and have 1/4 left over. Now for this one, 9 times 1/5. Again, we can't do 9 divided by 5, but we can do the repeated addition multiplication and come up with 9/5. 9/5 would equal 1 4/5. Sorry if I'm over on the edge of the screen. All right, boys and girls, good luck on the assignments that go with this one. Talk to you next time.